All right. So today of our unit on meiosis, what we'll be talking about is atypical chromosomal alignment, and basically how to read karyotypes as well. So, how to read a karyotype. So, first thing you need to know about a karyotype is, of course, humans have typically have 23 pairs of chromosomes. And whenever we say 23 pairs, it's much like your shoes. Whenever you say a pair of shoes, there's actually two there. So, we've already talked about how humans have 46 chromosomes, but that would be 23 pairs. Pairs 1 through 22 are called your autosomes. And if there's a disorder or some type of misalignment there of the chromosomes, then that would be an autosomal disorder or an autosomal misalignment. The 23rd pair of sex chromosomes, that's the actual sex chromosome pair. So if there's any type of issue there, then that would be considered a sex chromosome disorder. Remember, females are XX chromosomes, and the easiest way to see those is they're both the same size. And males have an XY chromosome, and that means that they're going to have one chromosome that's very large, and it's going to be paired with a chromosome that's very small. Now, I wanted to go ahead and go through this. It might be you might not really understand what I'm talking about until we get to the next slide, and I'll rehash over what this stuff is here. And then basically, whenever you try to identify or whenever you have to identify atypical alignments as autosomal or sex chromosomal, that's basically what you look for. Is you just have to know the pairing and then go from there. And you will have 5 different ones that you'll have to be able to identify. So the first thing we're going to do is we're going to go ahead and look at two karyotypes, one of a male, one of a female. And these two karyotypes will both just be in pairs, and there won't be any type of disorder with anything. So right here, what we have is if you look at this karyotype, if you notice that they're all paired together, these are the chromosomes. The stick-looking gummy worms are the chromosomes, and you'll also see how they get smaller as they go through it. So, like I said on the previous slide, is pairs number 1 all the way through pairs number 22 are going to be your autosomes. Now, we'll go and let you know that on your quizzes and on your test, not all of them, not all the pictures are going to be numbered. Sometimes they won't be, but they pretty much be laid out the same. So all you have to do is just count them. And also to help you out, the last pairing, so whatever's going to be in the bottom right hand corner of it, that's going to be your sex chromosomes. So right here we notice that even if I didn't have the XY there, the description I gave to a female sex chromosomes says that the chromosomes are both the same size. Now this one right here, I know that it's bent over a little bit, but that's just the shape of it. They bend, but they're both the same size there. So whenever you're having to try to identify a disorder or whether there is some type of misalignment here, basically what you're doing is you're looking for one that might have six. I'm sorry, I said six. One that might have three chromosomes instead of only two. All right. Or it could have only one chromosome present instead of two present. And so that's kind of what we're looking at there. So this right here would be a typical female's karyotype. We notice that all of these are in pairs. There's no triplets and there's no singles. And the last pairing are two same size chromosomes. So that lets us know that it's female. And the fact that there are no triplets or no singles, then that lets us know that it's a typical female karyotype with no disorders. So here's one. I wanted to show you one that didn't have them all numbered out, and you could still do the exact same thing. You just go through there and look at the pairing. You have one pair, two, three, four, five, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and the last pairing, bottom right hand corner, 23. Do you notice that this chromosome here, of the last one, of the last pair, is much larger than the one that's beside it? The one that's large is always going to be the X chromosome. The one that's small like this, that's going to be the Y chromosome. So whenever I look at this, I don't see any triplets or singles. So that tells me that we're dealing with a typical karyotype. And then because I get down here to the bottom and I see that it has a large chromosome paired with a small chromosome, a very small chromosome, that tells me that this is the XY. And I know that XY would be male. So this is a typical male karyotype. So I've been talking a lot about how you can have some that might have triplets or singles. Well, that's caused actually by a specific type of mutation, and that's called non-disjunction. So if you recall, whenever we talked about anaphase, and it doesn't matter if we're talking about meiosis or mitosis, as long as you still remember basically what's happening during anaphase of how the chromatids are separating, that'll help you out here. So during anaphase 2, basically, there's a failure of the chromatids to separate. All right? And whenever that happens, that means that a sex chromosome, a sex cell, is either, and that's what it says right here by gametes. Remember, that's a sex cell. That means that either a gamete will either have too many or too few chromosomes. And whenever we say that it has too many or it has 3 chromosomes instead of just 2, we call that trisomy. And tri being that prefix there, meaning 3, somy dealing with the root word for chromosomes. Whereas whenever we get over here to monosomy, mono, that prefix means 1, and still somy, still talking about chromosomes. So that would be a disorder that would result in non-disjunction. So whenever you're looking at a karyotype, and if you see one that has a triplet or a single chromosome alone, or a triplet set of chromosomes, then that means that that disorder was caused by non-disjunction. That this is what happened. The chromosomes failed to separate during anaphase 2. Okay, and I'm going to show you what this looks like here. So right over here on the left side of it, we see that we're going through meiosis, and so the first division is of course they divide. That's it. But then it goes through its second set of division, where now we have the haploid cells. The haploid cells. All right, and each cell has its chromosome. But we come over here to the right side where it talks about the non-disjunction. And if we look at this blue one here after the first stage of division, and then whenever it goes to the second stage of division, something happened there and it didn't separate correctly. And that meant that this cell did not end up with a chromosome, and this one ended up with 2 chromosomes. Now remember, somebody might be thinking, but wait a second, I thought you said that trisomy, that there would have to be 3. So remember, if this person, let's say that the one that says non-disjunction was the male, so this one that has the 2 blue chromosomes in it, that's the sperm cell. And let's say we go over here in under the column where it talks about what should happen. Let's say this was the side that was female. And so let's talk about this yellow chromosome here. Well, whenever this sperm cell that has the 2 blue chromosomes fertilize this egg cell with the 1 yellow, well, that would give you 3 chromosomes. And that's why that shouldn't happen. Because remember, that this individual, this organism should only have 2 there. And so that's why that would happen. Okay? Now, if we wanted to look at what monosomy would be, let's say this was the sperm cell that did it, that doesn't have a chromosome in it. Well, that means that it doesn't have one to add, so all that would be there would still be that 1 yellow chromosome from the female. So this right here is a karyotype drawing, that's all it is, of somebody with Down syndrome. So what you're going to have to do on these is you're going to have to figure out, is this person male or female? Does this person have any type of disorder? And then be able to name the disorder. All right, so whenever I look at this set of chromosomes, I see nothing but pairs. I see nothing but pairs. Now, just like the name suggests, trisomy 21, well, that means there's going to be 3 chromosomes on the 21st pair. And that common name is Down syndrome. Well, if we look down here at the 21st pair, there are 3 chromosomes there. So if you were to actually count up each individual chromosome, you're actually going to end up with 47 instead of 46. Now, that doesn't mean every trisomy is Down syndrome. And that's one thing that a lot of students get confused, because we're actually going to talk about some other types of autosomal disorders that that aren't Down syndrome, that are also trisomy. Like we're going to talk about trisomy 13 and trisomy 18. Now, I also just said another thing. I also said that this is an autosomal disorder. The reason why I know it's autosomal, because any type of disorder, whether you see a triplet or a singlet, anything between number 1, the first pair, and the 22nd pair, those are your autosomes. Now, I still say that we have to identify this individual as being male or female. So we look down at the bottom right-hand corner of the last pair, and then we see that there is a large chromosome paired with a small chromosome. Well, that would be X and Y. So this individual is male. So this would be a male individual with an autosomal disorder, and that autosomal disorder is trisomy 21, and its other name would be Down syndrome. Those 4 things that I just did, that's exactly what you will have to do on these images, on analyzing a karyotype. So here's another one for you. Down syndrome, still trisomy 21, trisomy 21. Down syndrome is trisomy 21. And now over here we have 2 X chromosomes. So this would be a female who has an autosomal disorder. It's called Down syndrome. Those 4 things. Now this one over here, now we have Klinefelters. So Klinefelters, it's another type of trisomy, and we don't call it trisomy 23 or anything like that. It's just known as Klinefelters. If you look at the autosome pairing from 1 to 22, you'll notice that each one of those are only paired together in couplets. So that means that this is not going to be an autosomal disorder. This is going to be a sex chromosomal disorder. So if we notice here, we see an X, a large X chromosome, another large X chromosome, and then a Y chromosome. So that means that this individual's chromosome set is XXY. And that's actually how you would write it. You would say that there are 47 chromosomes, so you would just write down the number 47, and then you would say, comma, XXY. And because you put XXY, that automatically tells you what set it is. And I can go back and show you what I mean by Down syndrome, doing the same type of notation. So with an individual that has Down syndrome, well, we know that there's going to be 47 chromosomes because it's a trisomy. So you would write down the number 47, and then you put a comma, and then you write down the sex of the individual. So this individual would be XX because this individual's female. And then you'd put another comma, and then you would just put down plus 21 because that tells us where that 47th chromosome is located at, and it's located on the 21st pairing. Okay, so that's Klinefelter's. Now this one's Turner syndrome. If you go through all of these, 1 through 22, you'll notice that they're all couplets. But then you look over here at that bottom right-hand bottom right-hand corner, and you notice there's only a single X chromosome there. So that means this would be monosomy. Now, how many chromosomes do you think there are in total? Now, you could count them, but if I know it's missing one, then it has to be 45 chromosomes. And so how I would write this down would be 45, comma, X. And so on this individual, I would say that this individual is female. I would say that they have a sex chromosome disorder, and the name of that disorder would be Turner syndrome. Here's Edwards syndrome. So on Edwards syndrome, there are 3 chromosomes on the 18th pairing. Now, because that takes place between 1 and 22, that means that's an autosomal disorder. And if you look at this individual, it has a long X chromosome, and then on the sex chromosome, then it also has a Y, short one, beside it. So that means this individual is male. All right, so if we wanted to write down that in that scientific notation, we would say this individual has 47 chromosomes, comma, XY, because they're male, comma, plus 18. Because we're saying there's an additional one on 18. Now, if you notice here, even though this is trisomy 18, we don't call this, just because it's trisomy, we don't call it Down syndrome. And the reason why I keep reiterating that is because I've had a lot of students in the past oftentimes make that mistake, because anytime they hear trisomy, they automatically want to go to Downs because they're more familiar with it. So that, again, this right here is an autosomal disorder. And now we are at Patel syndrome. Now I know over here, the image that I found for it, it had the XX or the XY. You actually went, that's just a box saying that, okay, this person can be male or female. So in Patel syndrome, this would be trisomy 13. This individual has 3 chromosomes on the 13th pairing. It's an autosomal disorder, and if it actually had picked either 2X or an X and a Y chromosome, then we would know if it's male or female. So remember that now these are the 5 that we've gone over. Now with Downs and Edwards and Patel, those 3 are all autosomal disorders. Please make sure that you go over and make sure that you know which ones they are and don't mix them up. Typically, people do mix up Patel and Edwards. They just forget which one goes with which. And then the 2 sex chromosomes would be Klinefelters and Turners. So another type of chromosomal disorder we'll talk about would be translocation. This is actually really similar to what happens with crossing over, but crossing over happens with homologous chromosomes. This happens with non-homologous chromosomes. So imagine each one of these chromosomes are like books of information. It's okay if, you know, the same book, which would be homologous, the same one, if they exchange some information, because it's still the same book. You know, if they both exchange chapter 12, guess what? They're both getting chapter 12. But in this case, if I sat there and went over there and took a book about Moby Dick, and then I wanted to exchange it, part of its chapters with, I don't know, the Deathly Hallows from Harry Potter, then that's really going to mess up the story a lot. And so that's basically what happens with translocations. We have a chromosome here that's from chromosome pair number 4, and it's trading with information from chromosome pair number 20. And whenever that happens, there's an issue. And so that's called translocation. This is a common way that it can be seen on a test question. You notice that the red one, it's information A through G. The one on the right is L through R. But then they exchange some information here. Remember, Even though, because of the fact, the reason why they use the alphabet there is to further show you that we're talking about two different chromosomes that have two different sets of information. And they're not homologous, so these are non-homologous chromosomes that are exchanging information. This is an image of one you might see. So even though there is deletion happening in number 9, if I asked you to find where translocation was happening, translocation isn't deletion. It means that we have to trade locations. So actually you have to go up to here to pairing number 1 and pairing number 3. If you notice, pairing number 3 was really dark, but then it has this much longer chromosomal stick on it that's a light colored with light colored bands. But we go over here to number 1, it's really light, and it's missing a piece right here. It's a lot shorter of a chromosome on this side, and so what happened here is they traded locations, and so that's a type of chromosomal mutation. There's really no specific ones we'll have to learn here. You'll just have to make sure that you're able to identify them. All right, and so that's all of day 2. So the biggest thing here that you're going to have to make sure that you know is you're going to really need to make sure that you know how to read and analyze a karyotype. Also, be able to understand that what non-disjunctions cause in that and how non-disjunction causes that and when that takes place. Remember, that happens during anaphase 2 of meiosis. Don't forget knowing an autosome from a sex chromosome, knowing how to identify an individual as a male and female, and then, of course, know the 5 misalignments there and be able to, accurately articulate those 5 misalignments. And that's it for Unit 7. Next class, what we'll be doing, we'll be reviewing over this information. Remember, a big part of this is really making sure that you can differentiate between mitosis and meiosis, so we'll be looking at that next time.